Okay, so we're going to go ahead and start with this warm-up here. I have one denominator is 6, the other one's 8. I need them to be the same. Do you guys remember LCD and what that stands for? Least common denominator. So I need a common multiple between 6 and 8, but the smallest one. So it's the smallest number that they both multiply up to. Up to, not divide. 24. They do both multiply up to 48, but that's not the smallest one. That's where the L comes into play. You want the smallest, the least common denominator is the least common multiple. They both multiply up to that, but it's the smallest one they have in common. Okay? So I know that the denominators need to be 24 in order to add them, so how do I make them be 24?
Multiply.
You multiply times what you need to get the 24. So what do I have to multiply the first fraction by to get 24? 4. Do I multiply just the bottom? No. I have to multiply the top and the bottom. So my first fraction becomes 20 over 24. So I have to multiply top and bottom by 4. Can't just change one part of the fraction. That would mess up the equivalence. Why do I have to multiply the second fraction by? 3, because 8 times 3 is 24. So I have 21 in the top and 24 in the bottom. So I multiply 7 and 8. Okay. Now that they have the same denominator, what would it look like if I add them together? 41 over 24. Since we made the denominators the same, we keep it the same. Don't try to add 24 and 24. It's not 48. All right, the denominator continues to stay the same, but just the numerators that add. Okay? What about this one when I throw variables into the mix? Let's look at the numbers and the variables separate. If I have just 2 and 5, could be 10. They both multiply up to 10, and that's the least common multiple. Right? But what if they have an x there too?
10x.
It's 10x. Right? So how do I get the first fraction, which is originally a 2x, how do I get that to be a 10x? 5. So in the top I'm going to have a 45, and the bottom I would have 10x. Okay? What would I multiply the second fraction by to get to 10x? 2. So what would the top be? 8. And then the bottom?
10x.
Alright, now that the denominators are the same, what would the numerator be?
45 minus 8.
Which is?
37.
Over 10x. Right, let's go up just a tad more difficult. It has 6x and 9x squared. Again, let's separate the numbers from the variables. What's the least common multiple between 6 and 9? Least common multiple, 18. It is true they both go or multiply up to 36, but you want the smallest one, which is 18. Okay? What do I do with the variables, though? The highest power. If you guys want to write a little note up here, you can remind yourself. When you guys are working with monomials that have variables in them, the LCD, or the common denominator, should have the higher power. So if you have an x and an x squared, it's the x squared that's going to be your common denominator. If you have x squared and x cubed, it's going to be the x cubed that's your denominator. Always pick the bigger power. Yes?
So, let's just say in a situation where your top number and your bottom number can simplify, for the final answer, can you simplify?
For the final answer, yes. So it's kind of weird how we work with addition and subtraction. We want to make our fractions uglier in order to combine them, but you can't simplify until after they're combined. But yes, you would want to simplify at the end of the beginning, which we couldn't do for either of these, right? But then if I need my common denominator to be 18x squared, what do I have to multiply the first fraction by to get that to happen? Multiplying times the 3 gets me to 18, but how do I also get the x squared? You have to multiply times 3x.
Oh yeah, because
it already has 1x, right? So it would be 3x over 18x squared. You have to multiply top and bottom by the same thing. So it already had 1x, so to get to the x squared, I had to have another x, right? So 3x. What would I multiply the second fraction by? It already has the x squared, doesn't it? So only 2, right? It already has the variable part, the x squared. I just need 18. So I'm going to multiply times 2. That gives me 8 over 18x squared. Now coming back to what Connor was asking, right? These fractions can be simplified as they are right now, but don't do that. Because if you try to simplify, you get right back to where you were, right? So you want your fractions to be bigger, a little bit more ugly, I guess is what you could call it, or improper, before you can combine them, right? So how would I combine these two? What would I write? Yes. Were the 3x and the 8 like terms?
No.
No. So I couldn't say that that was negative 5x, right? We can't do 3 minus 8 and then just stick an x on it. They're not like terms. So if the numerator is not like terms, you just leave them separate, but in a subtraction expression. Okay? So that's a little review on how we work with fractions when we're trying to add, subtract. We're going to take that exact same idea and apply it when the denominators are a little more complicated. Alright, so as a summary, when adding or subtracting rational expressions, you must have common denominators. Alright, so fill out that blank, common denominators.
So you can't simplify the last one over there?
No. Because remember, you would have to factor to simplify. You never simplify unless you factor first, and you can't factor that. But yes, you always do want to double check at the end to see if you can. Alright, so on this page, the entire first page, all we're going to do is practice finding the common denominator. Right? The process is a lot longer than just finding the common denominator, which we're going to see on the next page, the first 2 examples. But I want to make sure you guys are completely comfortable with just finding what the common denominator is before we get there. Right? The process itself is really not that difficult, actually finding what the common denominator is. Okay? So what you're going to do is you're going to factor the polynomials, and I should have been more specific. I only want the ones in the denominator. Denominator. You do not need to factor numerators. In fact, most of the time the tops can't be factored anyway. So you're going to factor the polynomials in the denominator, and then your least common denominator is going to be one representative of every factor that you see. So essentially, any repeat factors you're going to write down once, because you only need one representative of that factor. And then any individual factors that only show up once, you're going to write that down once too. So your least common denominator should have one representative of every factor that you have in your denominator. Let me show you what I mean. So we're not going to touch the numerators. And this is always true. You just jot down what the numerators are without changing them. It's the denominators that we have to factor. Okay? So I'm going to take my first denominator here. How would I factor that? Greatest common factor, 2. So that becomes 2 times x plus 2. Okay? How would I factor the next? The x method, because it's a trinomial. So I want 2 numbers that multiply to get what?
-6.
But add to get?
-1.
Okay. Which numbers do that? -3 and positive 2.
Because we have nothing in front of x squared, you can just do x minus 3 and x plus 2.
Correct. Hold on. My pen is acting up. Give me 1 second. Stop being obnoxious, please. Okay, so can I use a shortcut to factor that? Yes, because there is a leading coefficient of a positive 1, so I can write x minus 3, x plus 2. So the way that we're going to write the common denominator is I'm going to look at each one of my factors, and I'm going to write down one representative for each factor that I have. So what's one factor that you guys see? X plus 2. Oh my goodness. Why in the world did that happen? Alright, let me try this again. Alright, so one of my factors was... Right. Oh, now it's working. Give me a second. It chooses the most random times to glitch, and then it's fine afterwards. I don't know why it does this. Alright. X plus 2. What's another factor? X minus 3. Alright, is there another one? 2. We usually put the monomials at the front. Right? So I have one representative of every factor that I have in the denominator. You do not have to write the x plus 2 twice. That's what I mean by the repeat factors. If you see it occur twice, if there's a pair, you just write it once. Okay? So that's what your common denominator is. It's one representative of every factor that you have. Yeah, we have 2, and then x plus 2, and then x minus 3. That's one representative of every factor. So this is what you want your denominator to look like.
So we have to use all 3?
Yes, one representative of all of the factors that you have. Sometimes you have 2 factors, sometimes you have 3, sometimes you have 4. It just depends on how complicated your expressions look like when you factor. Now, taking that idea of what we were doing up here, if you know what the common denominator is, and we're not going to do this, but we're going to see that on the next page. If this is what my common denominator is supposed to look like, what's wrong with this one? This is what my denominator is supposed to look like in order to combine. What's wrong with this one? It's missing the x minus 3. So what you would do is multiply top and bottom by x minus 3. What's wrong with this one? It's missing the 2. So you'd multiply top and bottom by 2. That's what the next step would be. Right? So once you find what the common denominator is supposed to be, you just multiply the missing pieces top bottom onto each fraction. And then you proceed from there. Right? It's a lot of steps. You'll see that in the next page. Alright. This guy, we're going to leave the numerators alone, just like usual. You never have to work with the numerators until after we've figured out what the denominator is. Okay, we need to factor each of our denominators. So how would I address that first one? Okay, so it's a trinomial. So two numbers that multiply to get negative 4, but add to get 3. No. Negative 1, positive 4. Can I use the shortcut? Yes? Why? There's nothing in front of the x squared, so I can say x minus 1, x plus 4. Alright, what about the second denominator? It's the same thing, right? It's an x again, because it's a trinomial. So two numbers that multiply to get negative 8, but add to get positive 2. Negative 2, positive 4. Can I use a shortcut? Yep. So x minus 2, x plus 4. What about the last denominator? Alright, everybody should be writing this down. What's wrong with the last one? Okay, so what numbers multiply to get positive 4 but add to get negative 4? Negative 2, negative 2. Can I use a shortcut? Alright, now this one is a little bit of a special case. Right? You are not going to see something that's complicated, I'm almost 100% sure. Typically you only work with 2 fractions instead of 3, and they wouldn't normally look like this, but I wanted to give you guys a special case just in case. Alright, so what would be one thing I would have to have in the common denominator? What's one type of factor you guys see?
No.
There's an x minus 2, right? Yeah. Okay, so there's x minus 2.
But it's not in the first one.
That's okay. We're just writing representative of everything that we see.
Okay.
It doesn't have to appear in every factor. You just need to see it at least once.
X plus 4.
Okay, I see an x plus 4. And x minus 1. Are those all of the unique types of factors you guys see? Is there any other type? No, I took care of the x minus 1. I have the x plus 4 represented. I have the x minus 2 represented. Now this one is a special case because you actually have to write this. So do I. But you have to have x minus 2 squared.
Is it because it's present in 2 equations?
It's because there are 3 of them total. Remember how I said in the directions it says represent any repeat factors once? So x minus 2, if you wrote it just once, would mean that you had a pair of them. But you only have 3 of them. So this pair right here would be represented with 1, but I had 1 left over. So you really have 2 x minus 2s that you have to write. So I write it as a square.
So it's like you have 2 stored in that square, and then you got just 1 out here.
You're right, 1 per pair.
Yeah.
So because I took care of these 2 with the 1, and then I had an extra that I had to have in addition. So that's why it was squared.
So if it was cubed, it means
You had like
there'd be 4 in there.
no, you would have had 5 because it's 1 per pair and 1 per single.
Sorry, I asked that.
You're not going to see. That would be like you'd be adding 5 fractions together, which you'd never see. Again, this is a special case. It's 1 per pair. So if you guys want to do this, I have a lot of kids that like to cross stuff out as they're working. So we took care of the x minus 1 when we wrote that. We took care of the x plus 4, the pair, because it's 1 per pair. So I took care of the x plus 4. And then I took care of the x minus 2, it's just 1 of them, but then I had the 1 extra, so that's why I had to do this one. Again, that's a little bit of a special case. You guys won't see that, pretty sure. But in case you see 3 of something, you have to write x whatever squared. Okay, and again, this is what your denominator would have to look like, so you just multiply each fraction by what it's missing. We'll get into that on the next page. I just want to make sure you guys are okay with finding the common denominator, and then we'll work into actually making them have the common denominator. Okay, so that one's a little bit weird because it was a special case. Alright, let's move on to the next one. Do not change the numerator. We're going to look at those a little bit later. Right now I want to focus on just finding the denominator, so I need to factor the first denominator. How would I do that? How would I factor x squared minus 1?
X plus 1, x minus 1.
Very good. Hopefully you guys are catching those situations a little bit quicker. When you guys see the difference of perfect squares, you do the plus or minus of the square roots. What about the second one?
At the end.
There's GCF. So I take out the x, and then I have x plus 1 left over. You also need to be able to catch those GCF situations quickly too. Recognizing what type of factoring you need to do is one of those skills you guys need to be comfortable with.
Why can't you do x minus x and x plus 1? Yeah, right, because like, it's like squared.
But they're
Oh,
not
never
perfect
mind.
squares.
Never mind.
They're not perfect squares, so you can't do the same thing. Alright, so I need you guys to tell me what factors we have. What's one of the factors that we see?
X plus 1.
Okay, I see an x, I see an x plus 1, and an x minus 1. So again, you write one representative of each type of factor that you guys see, and only write one for each pair if you have repeating ones. So I repeat x plus 1s, but I just write it once. Right? So if this is what my common denominator is supposed to be, what's wrong with this one? There's no x, so what would I do? Multiply top and bottom by x. What's wrong with this one?
It's not x minus 1.
So I multiply top and bottom by x minus 1. Right? That's what we're going to see on the next page. Alright, what about this guy? Leave the tops alone. Factor the bottom. Can I factor the denominator of the first fraction? No? What would I do? Yeah, don't change it, right? You just write it down. Can't factor it, just leave it be. Okay, what about the next one?
X minus 3, x plus 3.
Yep. Difference of perfect squares again. Ooh. X minus 3, x plus 3. Alright, so everybody see how I did that? Okay, what would my common denominator be then?
X plus 3 and x minus 3.
Yeah, I have 2x plus 3, so I'm going to represent that pair once. And then I have a single x minus 3 that I also have to represent in the common denominator. So this is one of the nice situations that they give us, is when one of your denominators already has the common denominator. See how this one already has the common denominator? So I'd only have to fix this one. How would I fix this fraction?
Multiply times x minus 3.
Multiply top and bottom by x minus 3. Okay? And again, we'll see that in a second. Alright, I want you guys to try this one on your own. Try that one on your own, please. Anybody want to share out what they got for the common denominator?
X plus 3, x plus 3.
Okay, we normally put monomials at the front. Yes, that's what you should have gotten for the common denominator. This one, you don't have to factor the x plus 3 or the 5. This one I believe is x plus 3, x plus 1. And then you just pull out the pieces that you have in the denominator. Right? Is everybody okay with the factoring ones? Because these two are different. Is everybody okay with those? You need to know how to factor, so if you're still struggling with that, you've got to figure it out. Okay? Alright, so for these last ones here, can I factor it all? No. These ones you have to approach differently. We're not going to be factoring. We're going to do just like what we did in the warm-up. Okay? So the first thing you're going to do is you're going to separate numbers and variables. Okay. Moving my writing around. Separate numbers and variables. We're going to look at them differently. We're going to look at the numbers first and then look at the variables second to piece those two things together. So let's look at the 15 and the 5. What's the least common multiple between those two numbers? The smallest thing that they both multiply up to. 15 itself. Can't I multiply 15 times 1 and get 15? Why are you doing this to me? 15. Alright, so the number part is going to be 15. That's the common multiple. Now, what do you guys do with variables? We talked about that briefly at the top. I have an x, no variable, and an x squared.
Only one of them has the x. It's 15x and 5.
I know, I said already at the top, and I told you really dumb. When you guys are looking at variables, when they're in monomials, what are you supposed to do? Highest power. What's the highest power of the variables? X squared. So your common denominator should have the x squared part. Alright, so when you guys are working with things that are monomials, not factorable, but just monomials, you find the number part first, and then you just pick whichever variable had the bigger power. So your common denominator would be 15x squared. How would I get the denominator to be 15x squared for the first fraction? Multiply times x. How would I get the second fraction to have a denominator of 15x squared?
Multiply times 3x squared.
Yep. And how would I get this one to have 15x squared? Yes. So this one's a little bit different. Up here, you were able to see very clearly what it was missing. You're like, oh, that is missing the 3, so multiply times 3, or that one's missing x plus 1. It's really easy to spot what's missing in the ones where you factor. These ones you have to be a little bit more careful in how you multiply. If you have an x, but you need an x squared, you multiply times 1x to get that x squared to happen. So it's a little bit different how you would approach these with the multiplication. Okay? What about this one? I have a 2, 6, and 3. What's the common multiple, the least common multiple for all three of those numbers? 6. 2 multiplies up to 6. 6 times 1 is 6. 3 multiplies up to 6. So the numerical part of your common denominator is going to be 6. What would the variable part be? Yes. Always pick the piece with the higher exponent. So your LCD would be 6x cubed. And you would just multiply each fraction times what you need to get that. So is everybody okay with finding the common denominator with the factoring types and then monomial types? I need to make sure everybody's clear with this before we go on to the next page. Yes? Okay. So we're going to just do the first two examples. So this is going to be a longer process, all right? So the first thing you guys need to do is what we were just practicing. You need to find the common denominator, and then once you find the common denominator, you need to multiply times what you need to get the common denominator to be there. And then you proceed from there. You combine them and then see if you can simplify. All right, we are going to be looking for restrictions still. Those come from the denominator just like usual. All right, so here we go. I want to find the common denominator. I have a 7 and a 4. Remember, this is the non-factoring one. This is the monomials. So I have to look at the numbers and the variables separate. So what about 7 and 4? It's 28. You get the 28 from the 7 and the 4, and then what should the variable be? All right. So our LCD, which I'm going to write over here to get the information kind of isolated, is 28x. So how do I get my first fraction to have that denominator? Multiply times 4. It already has the x. I just need to get it to the 28. So if I multiply times 4, I'm going to have 8 in the numerator, and then my 28x in the denominator. Okay. What do I need to multiply the second fraction by?
35 over 28.
Okay. You multiply this one times 4, this one times 7. So I'm going to have what in the top? 35 over. Very good. Once you have the same denominator, all you have to do is now combine them. So I have negative 8, first fraction, minus 35. What was that? Negative 43 over 28x. Once you get here, you want to see if there's anything you can cancel or simplify. Once you get it to be one fraction, you would want to see if you can simplify. Can I cancel anything? No. So that would be your final answer. Right? And restrictions always come from the denominator. Since we know what the denominator was going to be anyway, you can just write down the LCD and get the restrictions straight from there. So what would the restriction be if your common denominator is 28x? 0. Right, so your x value cannot be equal to 0 because that would cause problems. Right, let's check out the second example here. Okay, this one, it is long. The process for these can be quite long. So I'm going to do the work for finding the common denominator up here, and I'm going to need all the space from this side of the page all the way to this side of the page. So make sure you guys are writing small and neatly. Especially if you write really big, you're going to need to write smaller. Alright, so I'm going to leave the numerators alone. I'm going to do exactly what we did on the last page. Always start with finding the common denominator. So the first thing I need to do is what? You need to factor, right? In the space over here, I'm going to go ahead and factor the first trinomial. So I need two numbers that multiply to get 2, but add to get 3. 2 and 1. Can I use the shortcut?
Yes.
Why?
There's nothing in front of
There's nothing in front of
it.
the x squared. So I can go straight to x plus 2, x plus 1. Right, what about the denominator of the second fraction?
There's nothing to factor.
There's nothing to factor, nothing to do, right? Alright, now remember, at this point you cannot cancel. You cannot cancel an addition or subtraction. You have to make sure it's one fraction. You have to do the actual addition or subtraction first before you try to cancel stuff. So do not try to cancel this x plus 2 with that x plus 2. Never ever do that for addition or subtraction. You're trying to make the fractions as big and bulky as possible so that you can actually combine them. You do not want to try to cancel stuff. You actually can't. Right? Because this is addition. You can't divide when you have addition. So don't try to do that. Alright, what would my common denominator need to be? I have an x plus 2 and what in my denominator? And an x plus 1. So my common denominator needs to look like this. In order to combine the two fractions, the denominator needs to look like this. So what's something good and what's something bad about our problem?
You need to put an x plus 2 where there's.
So the good thing is that this one already has the common denominator. The bad thing is that this one doesn't. Okay? So that's where my work is going to start. I'm going to start over here and it's going to snake its way across the page, right? So the first fraction's okay, so I'm going to write that down. You don't have to change the fraction that already has the common denominator. Okay, you don't have to change that. However, what was missing from the second fraction? An x plus 2. So I'm going to have to multiply top and bottom. I'm going to change colors. It's maybe dangerous when I'm doing it anyway. So we're going to multiply top and bottom times that piece that was missing, which was the x plus 2. Alright, you guys see that? Now it looks like what it's supposed to look like. It's supposed to have an x plus 1 and an x plus 2 in it. Doesn't matter what order, as long as it has both of them. Alright, so now I can combine them. However, there's a problem with the numerator. Can I combine this with that when it looks like this? What do you think you have to do? Yeah. That's why these can take a while. If there's any foiling or distribution or anything like that in the numerator, you have to do that. In the denominator, you can leave it looking like this. You don't have to foil the denominator. But in the numerator, you do. Because your numerator needs to be in standard form. You need to have a string of monomials so that you can combine them together. So in order to complete this question, I'm going to have to FOIL the numerator here and then combine like terms. That's why these can take a little bit of time to complete. So in my first numerator, I have the x, or negative x squared still. Then you guys can do the FOIL in whatever space you have left over, or if you're really good at FOILing, you can do it in your head. Alright, so if I FOIL, what would I get?
X squared, x 4x and then plus 4.
Yes.
Okay, quick maths.
I go straight into writing it over one fraction, which you can do now, right? The denominators are the same. You can write them as one fraction, now that the denominators are the same. And then I write the top like that after I FOIL. Alright, so I merged the two together, and then I had to FOIL those two to get this expression. Everybody see how I did that? Everybody with me? Okay, now what I need to do is neaten this up a little bit. How can I work with the numerator there? I have a negative x squared and a positive x squared. What happens there?
Cancel out.
They cancel each other, right? So then what's left in the numerator?
4x plus 4.
And what's in the denominator?
X would be x squared plus 7.
Plus 7, no. Don't FOIL the denominator. Leave the denominator as the common denominator. That's what it has been all along. Right. I know you guys are going to hate me, but we're actually not done. You're not done. You have to try to simplify. After you do the actual addition, when you fix the fraction that's messed up, and then you do whatever you need to combine them, and you simplify, now it's one rational expression. This is what we learned last time. If you have one rational expression to simplify, what do? Factor, and try to cancel stuff. Can I factor this? How?
4.
4. Yes, you can. That was the whole point of remembering to simplify. You can cancel this with that, so our final answer is going to be 4 over x plus 2.
Those are only restrictions.
No, your restrictions come from the common denominator. Remember, restrictions come from after factoring before canceling. So your restriction is going to come from your common denominator. So you're going to set both of those equal to 0. So what two numbers would not be allowed?
Negative 1 and negative 2.
Yes. Right, restrictions always come from the common denominator. So as soon as you write that down, once you know what the common denominator is, you know your restrictions. So you can do them at the same time. Right, but I will warn you, right? You may get here, and you've done everything great. You've done everything fine. But on the SOL, when you get here, you're going to look at your answer choices, none of them are going to look like that. So on the SOL, they're going to expect you to, after you've added them together, to then keep going and simplify it all the way. So always make sure you guys are checking after you combine them into one fraction, and you've simplified the numerator, you also need to now simplify the entire fraction, not just the numerator. So you may need to factor and cancel at the end too. Okay? Yes, Claire.
So like on the SOL, they would give us a problem like this, but they wouldn't ask us for like the least common denominator.
No, they would just say, here's this, add them. Or here's this, simplify, go. Yeah, they wouldn't give you any extra little stuff to do. Alright, that's where we're going to stop for today. Does anybody have any questions on that? No? Alright, so you guys can see the process is quite long, so you guys might want to start doing a couple questions on the homework so that you're not trying to do an hour and a half long homework assignment right before it's due on Thursday, right? So you can do a couple questions just to get started. Alright, so why don't you go ahead and prepare? I'm going to give you the quiz.
I'm fine.